In this video, we are going to talk about chi-square test of independence, and we will do a problem about that. Okay? So test of independence is used to determine whether there would be any kind of relationship between row variable and column variable in a contingency table. So we'll be given observed data in a table, and we'll try to see if there is some kind of relationship between the rows and the columns. And now the test statistics is again similar. However, in this case, we will be going through all of those rows and columns, okay? Each cell of the table. I and j means the number of rows and number of columns. And the expected counts, whenever you are trying to find out the test of independence for these rows and columns, you also need to figure out the expected counts. Okay, so to find out the expected counts, you need to come up with a new table, and this is the formula where by which you get the new table for which each of the cells will be calculated in this way. All the expected counts in each cell should be greater than or equal to 5. Degrees of freedom is equal to number of rows minus 1 times number of columns times minus 1. And then after that, p-value, we will always use the GeoGebra probability calculator to do that, and it's straightforward. Main question is, are the rows and column variable dependent upon each other? Are they independent or dependent? We will try to figure out. If so, the null hypothesis always consists of independence, that it is always saying that rows and columns are independent. However, alternative hypothesis says that the rows and column, they are not independent, or they are dependent upon each other. So now let's head over to one of the problems that we have in a book, in our book. Okay, in a volunteer group, adults 21 and older volunteer from 1 to 9 hours each week to spend time with a disabled senior citizen. The program recruits among community college students, 4-year college students, and non-students. In the table below is a sample of the adult volunteers and the number of hours they volunteer per week. Is the number of hours volunteered independent of the type of volunteer? Okay, so is there any connection between the types of volunteers and the hours of volunteers? Okay, so between the rows and columns. So that's what we need to figure out. Okay, so first of all, let us go for hypothesis. So the null hypothesis and alternate hypothesis can be found out in this way. The last sentence, if you read that, then it is saying that is the number of hours volunteered independent of the type of the volunteer. The number of hours volunteered is independent of the types of volunteer. Alternative hypothesis is, so alternative hypothesis is the number of hours volunteered is dependent of the type of volunteer. In this case, there is no relation, and in this case, there is some kind of relation, dependent and independent. So always null hypothesis is, it talks about independence. Alternative hypothesis, it talks about dependence. Now we need to come up with a new contingency table. We will talk about that here. First of all, let's go for alpha. Alpha equals to 0.05. Let's assume that the alpha level or the significance level is 95%, or alpha is 0.05. Okay, since nothing has been given. Now we need to find out test statistic, and then we need to find out the p-value. Okay, so to figure out the test statistics, we first need to come up with a table. This new table that you are seeing downstairs, it's the table for expected values. The expected values that you might want to figure out is row total times column total divided by table total. So first one, okay, so you multiply the row total and column total and place it divide by this one over here. Okay, so this would be 255 times 298 divided by 839. Similarly, you multiply this one and place it over here, divide by this one and place it over there. 255 times 379 divided by 839. Okay, and you keep on doing that one. Okay, 255 times 162 divided by 39 would be there. Now go for this one, and then go for 290 times 298 divided by 839. So that's what you need to do for all of the cells. Now this is quite time consuming. Okay, So what we do is write down, or we input all these values in our GeoGebra probability calculator, and let's see how it would be done. So let's go to GeoGebra probability calculator, go to statistics, and click on this drop down menu and go for chi-square test. In our observed table, there are 1 to 3 rows and 3 columns, right? So that's 3 rows and 3 columns. And let us copy all the data, okay, in this cells. So you can see that this is 162, 279, and 298. Okay, so that's fine, and it doesn't give us the row totals, but that's fine. Okay, and if you the calculations that we did for this expected values, if you click on this expected count, then it will show up all the values. Okay, then degrees of freedom is of course 4. Okay, since 3 minus 1 is 2 times 2 is 4, right? So that's the degrees of freedom. And the chi-square, the test statistics is 12.99. P-value is 0.01. So let us write that down. This is 12.99, and the p-value is 0.0113. Okay, so you can realize that alpha is greater than p. Okay, since we know that 0.05, that's 5%, is greater than 0.0113, which is nearly 1%. We reject the null hypothesis. So we reject the null hypothesis, and finally in the conclusion what we write is there is sufficient evidence that the number of hours volunteered is dependent upon the type of the volunteer. Okay, so we write that down. So we have sufficient evidence that the number of hours volunteered is dependent of types of volunteer. So that's how we go for test of independence. Thank you.